Okay, let's jump right in. We're going to talk about this really revolutionary idea. This idea that the future of our technology isn't just in some high-tech lab. Nope, it's actually hidden in the ancient wisdom of the natural world that's been all around us this whole time. So what in the world do these three things have in common? I mean, a kingfisher's beak, a lotus leaf, a burdock seed. On the surface, not a whole lot, right? But if you dig just a little deeper, you'll see they're actually connected to some of our most advanced and even our most common technologies.
Well, here's the secret. Every single one of them has been a blueprint, a direct inspiration for inventions that have totally shaped our world, often in ways you would never, ever guess.
And this whole concept, this incredible idea, it actually has a name. It's called biomimicry. You can think of it as the art and science of looking at life's genius. I'm talking 3.8 times billion years of research and development, and using that to solve our own problems. So let's be clear, this is not some newfangled idea, not at all. For centuries, some of the greatest minds in human history have been looking to nature to figure out our biggest, most complicated problems. I mean, go all the way back to the 15th century. You've got guys like Leonardo da Vinci who were just completely obsessed with this. He filled notebook after notebook with these super detailed drawings studying how birds and bats fly. He was convinced, absolutely convinced, that if he could just crack their code, he could build a machine that would let us fly too.
And that obsession? It just kept going for centuries. You had George Cayley looking at a trout, of all things, to figure out the basic principles of flight. Then you had the Etrich brothers, who found the secret to a stable glider in a seed from a vine. The theme is always the same. Nature was the original teacher.
And here's the thing, right? Nature has had literally millions of years to perfect movement, to perfect efficiency. And engineers today, well, they're finally catching on and starting to take some serious notes. Okay, this is such a cool example. It's basically solving a physics problem with biology. So Japan's famous bullet trains had this huge issue. When they'd blast into a tunnel, they created this massive, deafening sonic boom. The solution, believe it or not, came from the kingfisher. You know how it dives into water with almost no splash? That's because of its beak. So engineers literally remodeled the front of the train to mimic that beak and boom, a quieter, faster, and even more efficient train. And sometimes nature's solutions are, well, they're not what you'd expect. Take the boxfish. It looks kind of clunky, right? You'd never pick it out as a model for aerodynamics. But its shape is unbelievably stable and has super low drag in the water. So what did a car company do? They copied its shape, built a concept car, and managed to slash fuel consumption by a third. Just amazing. All right, so it's not just about copying shapes and movement. Biomimicry goes even deeper. It's also about learning from the absolutely incredible materials that nature knows how to create. So probably the most famous example of this whole idea didn't come from a fancy lab. It started with a guy, a Swiss engineer named George de Mestral, just taking a walk in the Alps with his dog. When they got back, his dog was covered in these annoying little burrs. But instead of just brushing them off, he got curious. He put one under a microscope and saw this genius system of tiny little hooks. A whole decade of work later, he patented it. We know it today as Velcro. And that simple little story about Velcro, it points to something so much bigger. Think about it. Nature makes stuff like spider silk or the shiny material inside a seashell. And pound for pound, that stuff is tougher than steel. It's even tougher than Kevlar, our best synthetic fiber. It's just wild.
But here's what really blows my mind. How nature makes these super materials. Scientists call it gentle chemistry. There are no blast furnaces, no toxic chemicals, none of that. It all happens at room temperature, just using whatever is available. This really gives us a peek into a future where our own factories could work just as cleanly and efficiently as a single living cell. It's a total game changer.
Okay, so we've talked shapes, we've talked materials, but the inspiration goes even deeper. We're now moving beyond just copying one single thing, and we're starting to learn from the genius of entire systems in nature. Have you ever seen a flock of birds just turn all at once in perfect sync? It's amazing. How do they do that? There's no leader shouting orders. Well, back in 1986, a computer scientist named Craig Reynolds cracked the code. He figured out they're all just following three incredibly simple rules. And get this, those exact same rules are now used to coordinate swarms of robots and make those super realistic crowd scenes you see in movies. And this idea of swarm intelligence is everywhere you look. The way ants find the quickest path to food, that's inspired algorithms that make our internet faster. Those crazy termite mounds that stay cool in the blazing hot desert, they've inspired buildings that don't even need air conditioning. There's even an 800-year-old village in China that was built in the shape of an ox, and it uses a water network modeled on the animal's digestive system. I mean, how cool is that?
And all of this, it leads us to the biggest idea of all, the really profound one. What if we stop just copying one thing at a time, and instead we start mimicking nature's entire philosophy?
This right here is the absolute core of the modern biomimicry movement, a message really pushed forward by the biologist Janine Benyus. It's about a complete shift in how we see the world. We need to stop seeing nature as just a warehouse of stuff we can take and start seeing it as our mentor, our most experienced mentor at that.
So the end game here isn't just about copying a cool wing design or a tough shell. The real goal is to copy nature's entire playbook, its whole operating system. I mean, think about it. It's a system that creates zero waste, runs entirely on solar power, is completely self-sufficient, and its main byproduct is creating the conditions for more life. That's the model we should be aiming for.
And this way of thinking is already leading to some mind-blowing breakthroughs. You've got farmers building systems based on natural prairies that are just as productive as big industrial farms but are totally sustainable. We have engineers using wetlands and microbes to clean our wastewater using almost zero energy. And scientists, they're getting so close to creating artificial photosynthesis. Imagine that, turning sunlight directly into fuel, just like a leaf does every single day.
So, okay, why does any of this really matter? Here's the bottom line. We are literally surrounded by solutions. Genius, time-tested solutions. The answers to our biggest challenges, energy, materials, food, you name it, they're not some far-off dream for the future. They're right here, right now, all around us.
So here's what I want you to take away from all this. The next time you're outside and you see a spider web, or you watch a flock of birds fly by, or even just notice a little weed pushing its way up through the pavement, take a second. Remember that you're not just looking at nature. You might, just might, be looking at the blueprint for our future.